Okay, now I'm going to show you how I made the the toolpaths to carve the shell. First thing I did, I'm using Aspire here, and the first thing I had to do was set up the job. So I knew that I wanted the font Basin to be about 18 inches square. So I made the job size 18 by 18, and I wanted to make it as deep as I could fit on my machine, and 3 inches is about as thick as I could go. So the shell would be 3 inches, tall by 18 by 18. It's going to be a two-sided job, so I clicked for the job type as double-sided. This is a nice option that was added to Aspire a couple of years ago. It makes it easier than making individual files for top and bottom. So by clicking that, gives you a choice of where you want to zero the Z height, and I decided that I was going to make my be very careful on the thickness of my material, so I would then zero for the top part of the shell. That would be the convex part. I would zero on the top of the material, and then for the concave part I would zero on the bottom of the material. I would also zero on the lower left hand corner of the material, and it gives me a choice of how I want to flip the material to carve the other side. I decided to flip it top for bottom. And modeling resolution, I always like to have a high modeling resolution. So the actual shell, I fortunately did not have to design. I could go to the clip art that's offered with Aspire and take in the scallop shell design, and there you go. All I have to do is manipulate this to get it like I want it, and I sized it to fit within my material. And then I said, okay, that's the top, and let me show you what that looks like in a 3D view. Okay, so when I brought the shell in by itself, it is the convex representation of the shell. That's what comes with the model. And if I flip that upside down for you, you can see that it's just flat. So I had to figure out how to make the concave part of the shell, given that all I was supplied was the convex part in this scallop shell number 50186 alpha. Well, to do that, I copied this. Let's see, I just right click and copy to the other side, and what happens is, I'm going to flip to the other side now, it actually copies it over here, and there you can see that. But I had to do a couple of things. One of them was I had to make this a subtract, here, let me bring that up, combine mode. If I had just left it as an add combine mode, let's see how that would look. It would end up looking like a convex shell again, but I needed it to be a concave shell, so I did subtract combine mode. I also had to give it some thickness. If I had not given this thickness, if I had just simply copied the shell to the other side in the subtract mode, it would have been a zero thickness shell. So what I had to do is I had to offset the model, and I offset it by 3/8 of an inch. And the way to do that is up here there's a little tool, create a component by offsetting visible model. And what you do is after you copy to the other side, you hit that thing and you just put in whatever thickness you want, and I'm going to cancel that because I already did that, and it'll give you a 3/8 inch offset, which gives you, and you can see I've got some thickness in that model. With that done, the next part was to set up, let me go back to the top, set up for the actual cutting. So I thought, okay, well, I got to really think hard about this. I'm using a 3-inch thick block of material, and my bits, you know, typically on a long bit, it might be a 3-inch long bit, but you know, you got to stick it into the collet an inch, and the cutting length on a long bit, you know, is usually not more than about 1.5 inches. So I had to really think about how I'm going to be able to cut into a 3-inch block and go, you know, pretty much all the way the full thickness. So the solution is, you got to, before you start cutting the model, you got to cut away a whole lot of excess material from the block so that the collet nut doesn't bottom out on the actual block itself. So I made an outline of the shell, and to do that I just use this tool up here, create vector boundary around selected component. When you do that, it makes this, here I'll highlight it, this little boundary. And then I offset that boundary using my drawing tools over here on the left, offset selected vectors, and I just offsetted it out far enough where I thought that the collet would clear when it was trying to, you know, eat away this material. And that, you know, that really did the trick for most of what I had to do, and I'll get into this a little more later. At that point, I thought I could probably go ahead and set up some Toolpath files. So I thought, okay, well, I'm probably going to screw this down to the spoil board in the 4 corners, which is pretty much how I always do my work. And when I cut this thing, if I was to cut the inside part first, okay, right there, that would leave all this material around the edge, you know, so I could screw against the spoil board. And so I decided I'd go ahead and cut the inside first, and then I'd flip it over and cut the convex portion, and that final cut, you know, with the fine bit is going to go right down to the edge and just about release this from the block itself. Okay, yeah, think about that for a minute. All right, so if that was going to happen, I had to add a few things. I had to add some tabs. So the way you add the tabs, again, you go to the clip art, and they've actually got a 3D tabs in there. So I picked out the 3/4 inch tab, and these are just little 3D models. Drag it on in, and then you can rotate it, set it in there. It ends up merging as part of your file. So let me get rid of that because I already had added them. You can see there's one at the bottom, one up on the upper left, upper right, etc. And you notice all these tabs have a merge combine mode, which means they become part of the model. And if I look at it in 3D view, you can see the tabs. All right, and once since they're part of the 3D model, when the 1/8 inch ball nose comes down and cuts, it won't cut through the tab because it's part of the model. And that way, these little tabs hold the wood in place at the point where I'm cutting all the way around this outline. Okay, so with all that done, I went ahead and then created a component from the visible model with draft added. What that means is it will take all of this stuff here, the shell model and all the tabs, and combine it all into a single model with draft added. Now what draft is the program looks at the edge of the model and puts a little slope to it. So for example, if I had a model that had vertical sides and I added 5 degrees of draft, the program would then make a 5-degree slope out from the edge. And by doing that with this shell, I would be able to make this look more like a real seashell. I went ahead and made a 45-degree draft version. Now you can see the nice 45-degree angle on there. So I went ahead and put that draft in there, and then combined all the tabs together to make another combined model called Model Merged. And there it is with all the tabs. And that's what I ended up actually cutting. The underside, I went ahead and actually changed the offset a little bit to be only 1/4 of an inch, because I decided 3/8 of an inch was going to be a little too thick. So that's what I finally ended up cutting, 1/4 inch thick, and you can see how the tabs look on the other side because they're part of the model. And flip that back over, and now we're ready to think about cutting. But again, I had to think about how to get some of this excess away, and this ended up being kind of an iterative process, to tell you the truth. I started out with my model and the tabs and an outline. I offset the outline, and this version here is a little smoother than what you saw before, and used my 1/2-inch bit to cut away enough where I thought that the collet nut would be able to fit down inside. I actually ended up having to make a separate file and cut away a little more because I didn't do enough the first time. I discovered that after I was cutting. And the nice thing about this kind of work is you can just stop the cutting, you can go back, modify the file, modify your toolpaths, and just start cutting a new toolpath to give me a little more clearance. I also found out that when I started cutting way back in here, I had to actually cut away a whole bunch of this upper corners because on the ShopBot desktop machine, there's a big plate that holds the spindle in place, and that plate was going to bash into this material. So it's kind of you got to really think hard when you're doing deep work like this about what the machine is going to do, and I didn't quite figure it all out before I started cutting, but I figured it out before I started breaking things, which means I could just stop the cutting, go back and make a new toolpath file to get rid of these parts here, leaving a nice place where I wouldn't cut into my hold down screws. Okay, so I'm ready to start cutting. The first thing I did though was, and you can just barely see circles up here in the corners, what I did was I ended up using 4 long, I had these 3-inch long screws, like deck screws, and since it's a 3-inch long piece, I had to actually countersink 3/4 down. So I took a drill bit and cut 3/4 down into the block, and then drilled the rest of the way for the screws. So the screw head was 3/4 of an inch into the material, which means that the threads went 3/4 of an inch into my spoil board. I did that on both sides since I was going to be flipping this top for bottom. As long as I put these screws 1/2 inch in from each corner, it should flip and give me reasonable accuracy. So the first cut was, let me go ahead and bring up the 3D. Okay, the first cut was the concave rough cut, and I'll show you that here. I used a 1/2 inch end mill, and bring this up here, 1/2 inch end mill, pass depth 1/4 inch, which I usually try to limit my pass depth to about half the diameter of the bit, and feed rate 3 inches per minute, plunge rate 3 inches or per second. I find that all my bits just cut fine at that rate. So I left a little machining allowance for the, just give me a little extra, just in case there's any inaccuracies, to make sure that this thing really looked like the inside of a shell when I was all done. I used a Z level, which basically makes this look like a topographic map, and it just cuts away the waste much faster than using a raster strategy. Calculated it out, and let's go ahead and see what this looks like here. I'm going to preview the selected toolpath. I'm going to use the draw tool so you can see what it's doing. On this, I don't have to worry at all about the collet nut hitting this material because as the bit goes towards the center, it goes deeper and deeper, but it's gradual enough slope that the collet nut doesn't get anywhere near the edge of the material. Now when I do the top side later, you're going to see it's a whole different story, and then you'll see why on that. There you go. Now I can put it at a little angle here. You can see how that steps down. It's like a topographic map or an open pit mine kind of a thing. All right, and you can also see how the edges here are so gradually sloped that there's no danger of the collet bumping into this material. The next cut I did was the finish bit, and let me show you how that's set up. Okay, I used a longest bit I could find, which worked well with my machine, because remember I only have a 5.5 inch height on my Z, because this is just a little ShopBot desktop. So this bit is 3¼ inches long, fits into the collet about 1 inch, so you end up with about 2¼ sticking out, but you only have 1.5 inches of cutter length at 2.4 degrees on the side, the cutter angle. So I used about a 10% step over on this, which is a little more than I usually use, but I knew I'd be doing some sanding on this anyway, so I figured why spend all the extra time with like a 6% step over, which would just take longer to cut since I'm going to sand anyway. Okay, now I also use 3 inches per minute or per second cutting rate, because this is not taking a very big bite, and that just works fine with my machine. Alright, so I went ahead and calculated that out, and let's show you what that looks like. Now in this one I'm using a raster strategy, meaning the bit is going back and forth, as opposed to an offset, which would be starting in the center and then getting bigger and bigger circles. And the reason I was comfortable with that is because I knew the bit would be starting with very little depth on it, and I wouldn't have to worry about it plunging deep and causing any damage. Alright, with all that cut then, now it's a matter of just flipping this top for bottom and then cutting the bottom part. The first toolpath I did was the rough, using a 1/2 inch bit, and there you can see what I used, 1/2 inch end mill, cutting to the selected vector. A little bit of extra machining allowance there, why not? I used a Z level type of strategy, which goes faster. And let's go ahead and take a look at what that one looks like. Okay, you can see the file there, and I'm going to preview the selected toolpath there. So you can see how it started going around in the Z level. It's cutting. This is going to take a while. It's cutting the first level, which is a 1/4 inch down, because that's what I set my depth at, my cut depth at. And so you can see how it left full height right here in the middle and started cutting down a 1/4 inch in a stepped fashion. Now the next cut is going to be stepped out a little farther. Okay, now it's cutting another 1/4 inch, so this is now a total of a 1/2 inch deep. You can see how it steps down, kind of like a topographic map, and it just does that all the way through until you get all the way to the bottom. Okay, now at this point, I want to point something out. I've gone down 1, 2, 3, 4, 5 steps. That's 1 1/4 inches. The next step is going to be taking me down to 1.5 inch depth. But there's my tool, and here's the edge of the material. And that means the collet is going to bash into this material, which is why before I did this cut, the rough cut, I had to make those clearances. And so that's why I kind of did things in this order for you, so you could see what the problem would be if I didn't make my clearance cuts first. So what I actually did was not cut this rough cut until I'd done all my clearance cutting. And as soon as this is done, I'll show you what the clearance cutting ended up looking like. Alright, so that's what the rough cut looks like if I didn't put in the clearance. And of course I would have bottomed my collet nut onto this material long before I got to this depth. So the first cut I actually did was called convex clearance, and you can see that that cut is just around the edges here. Let's go ahead and show that one. So all I'm really doing is I'm just cutting away some material so that my collet nut will not, bump in. And I think I went down like 1 inch or something like that. Yeah, went down like 1 inch. And later on I found that wasn't enough, so I actually had to do a toolpath here called more clearance to give me even a little more. And this particular more clearance toolpath I did after I started cutting, and I realized it just wasn't going to work with the original clearance I made. So maybe I should have just done a whole lot more clearance in the beginning, but I didn't really see that one coming. There we go. We'll get that all knocked out. And as I said, I realized, again, after I'd done all this clearance cutting, that the carriage for the Z-axis was going to hit the tops here on the corner. So I had to even do another clearance cut called clearance corners. And with that, I actually was very careful not to cut where the hold down screws were. Even though I had resets the hold down screws by 3/4 inch, I didn't want to take any risk of running the end mill into the steel of the screws. So that's why I made those big clearance holes, and that's how that looks. Turns out when all was said and done, my calculations were good, and my cutter did not go down the full depth of the screw heads. But better safe than sorry. And all I did was just saw these off with a little flush cut saw. So now I was deep enough to be able to do all this interior cutting. Okay, so with all that done, then the next cut was the finish cut, and that uses a 1/8 inch tapered ball nose bit. I bought special bits that were really long for all this work. I think the bit itself is like 3 1/4 inches long, so it fits into the collet, leaving about 2 1/4 inches sticking out, which is still not deep enough, which is why I needed all this clearance cut. And on that, let me go ahead and show you that. Okay, so that was cut to the, also to the selected vector, which was the outline of the shell. And I used an offset strategy. And there's the settings I put. You can see that bit was in 1.5 inch cutter length, 2.4 degrees angle, and the bit was 3.25 inch overall. It's a 1/4 inch shank bit with a 1/8 inch tapered ball nose on the end. Okay, you can see how this works here. 10% step over. Okay, so that's what that looked like. Now let's go ahead and show you the cut. I did an offset strategy instead of a raster strategy on this because I wanted to really be careful and be able to see what the machine was doing when it got very close to these blocks. If I'd started with a raster strategy, it would have started cutting, usually it's down the lower right hand corner, and that means the tool would have gone full depth for the very first cut. And I just didn't want, I wanted to be able to watch and make sure things weren't going to hit. It's a whole lot easier to watch it creeping up on the edges. So we're getting close to the end of this cut. You see we just have a little bit of the second to last level, and then we're going to cut into the last 1/4 inch level. You can see up here in the left hand corner the tab, that the tool will cut over this tab and leave it a nice rounded tab. Alright, so this is pretty much what it looked like when I pulled it off the machine, which you'll see in the next part of the video. And let me flip that around for you. I can go ahead and show you that we got the inside there, the concave part, and the convex part. And all I got to do is cut this free of the waste, and we're done.